Welcome back to Principles Engineering, and we're back at doing some more stress strain calculations. We skipped ahead a couple. We're now on number 3, and what we're going to look at on this particular one, problem is written up there, is determine the maximum load that a 0.50 diameter steel rod can support if the normal stress on the rod must not exceed 24,000 psi. So that's our problem. Let's go ahead and look at the methodology that we're asked to use here. And let's first start out with what we know about the rod. And actually, let's start out with a little bit of a drawing here, because that'll be fairly useful for us. So let's do our drawing in this magenta color. And we're going to start out with, and I'm going to draw it from a side view, kind of a, well, I'll do my best here. Oops. I want a pen. And here I've got my rod extending down. Probably not as straight as it could be. It's a wavy rod. Doesn't matter. It's a sketch. And what I have is I've got a pressure on this rod. So I've got a force pulling up from whatever it's suspended with, and then a weight pulling down on that rod. My diameter across it, 0.50 inches. So let's write what we know. And there's my force. Now if it's in static equilibrium, and I'm going to put it as a force of tension, it's in static equilibrium. We learned earlier that the bar is not moving, or the rod's not moving, and that's why I've drawn the force on the top and the bottom. I've got a force pulling down and a force on the top, which puts the overall unit into tension. So what do I know about this? I know that my strain on the rod here is 24,000 psi maximum. I also know that the diameter that I was given of the rod equals to 0.50 inches. My unknowns are my area, and I also don't know really what that force of tension, that tension load is. But I do know a few equations to calculate my area. And the area from my formula sheet of a circle equals to pi r squared, or pi d squared divided by 4. I also know that sigma is calculated as a force divided by an area. So looking at our equations for area, the area equals to pi d squared divided by 4. If I substitute in pi times 0.5 squared divided by 4, and that's inches squared, then that equals to about 0.1935 inches squared. Now looking at my strain within the rod, we've said that that's going to equal to the force divided by the area. And my question is, what is the force? So I can manipulate this force divided by area quite easily, and what I can do here is I can multiply times the area, and then I arrive at area times my maximum sigma equals to the force tension max that's allowed. So let's go ahead and substitute a different color here, because I know that my area is 0.1935 inches squared. I know that my maximum sigma is 24,000 pound force per inch squared, and you can see that my units will cancel out quite readily here. My inches cancel out, and I multiply this out, And what I will arrive at is approximately 4,712.4 pounds force. So my final solution, because they asked me to use a precision of 100, so my precision of 100 for this answer is going to then make it 4,700 pounds force. And that's in tension right here. So that's problem number 3. I hope that helped. Thanks for watching.